Look around you. The world is full of shapes. Among the most fundamental is the triangle, a simple shape with 3 sides and 3 angles. Trigonometry delves into the relationships within right-angled triangles, those with one perfect 90-degree corner. These right triangles are everywhere, hidden in plain sight. A leaning ladder forms one against a wall. Trigonometry gives us the tools to understand the connections between the lengths of a triangle's sides and the measure of its angles. Imagine trying to measure the height of a tall tree. By measuring the distance from the tree and the angle of elevation to its top, we can use trigonometric functions to calculate its height. Whether it's measuring distances, determining angles, or analyzing forces, understanding triangles is key. You might remember the Pythagorean theorem from school, a squared plus b squared equals c squared. This famous equation links the sides of a right triangle, specifically the 2 shorter legs, a and b, to the longest side, the hypotenuse, c. But the Pythagorean theorem has limits. It only tells us about the relationship between the sides, not the angles. What if we need to know the angle a ladder makes with the ground for safety? That's where trigonometry's unique strength comes in. Trigonometric functions provide the missing link. They connect the ratios of a triangle's sides to the measure of its angles. These functions, with names like sine, cosine, and tangent, unlock a whole new level of understanding about triangles. This ability to work with angles is what sets trigonometry apart from the Pythagorean theorem and makes it an essential tool in numerous fields. Sine, cosine, and tangent might sound intimidating, but they're just fancy names for specific ratios within a right triangle. Each one relates an angle to the lengths of 2 sides. Sine, often shortened to sin, is the ratio of the side opposite an angle to the hypotenuse. Imagine looking up at that tall tree. The sine of the angle of elevation connects the tree's height, opposite side, to the imaginary line from your eye to the top, hypotenuse. Cosine, or cos, focuses on the adjacent side. It's the ratio of the side next to the angle to the hypotenuse. In our tree example, cosine links the distance from the tree, adjacent side, to that same imaginary line, hypotenuse. Tangent, shortened to tan, connects the 2 shorter sides. It's the ratio of the opposite side to the adjacent side. Mastering these functions opens the door to solving countless problems involving triangles and their applications in the real world. Trigonometry isn't confined to textbooks. Its principles underpin fields as diverse as astronomy, architecture, music, and even medical imaging. Understanding triangles and their properties allows us to explore the universe, design safe structures, and even analyze sound waves. Astronomers use trigonometry to calculate distances to stars and galaxies, relying on the concept of parallax. By measuring the tiny shift in a star's apparent position as Earth orbits the Sun, they can construct a triangle with Earth, the Sun, and the star at its corners. Trigonometry then reveals the star's distance. Architects rely on trigonometry to design sturdy buildings and bridges. Calculating angles and forces within a structure ensures its stability and safety. Even music relies on trigonometry. Sound waves travel in repeating patterns, and we can represent these patterns using trigonometric functions. These are just a few examples of trigonometry's far-reaching impact. In today's world, we have calculators and computers to instantly compute trigonometric functions. Punch in the numbers, press a button, and voila, the answer appears. But this ease of calculation shouldn't fool us into thinking we don't need to understand the underlying principles. Imagine trying to bake a cake by simply throwing ingredients into a bowl without following a recipe or understanding how each ingredient interacts. Similarly, blindly relying on calculators without a grasp of trigonometry can lead to errors and misinterpretations. Understanding the concepts of sine, cosine, and tangent allows us to choose the right function for a given problem. True mastery of trigonometry comes from understanding its principles, not just memorizing button presses.